I want to talk to you about something called an empirical formula and a molecular formula. So a molecular formula is the true number of atoms of each element in the formula of a compound. But an empirical formula is the lowest whole number ratio of atoms in a compound. Formulas for ionic compounds are always empirical. They're in their lowest whole number ratio to begin with, but a molecular formula may or may not be. So here's an example. So there's a molecule, an organic molecule called benzene, and its formula is C6H6. Now, each of those is divisible by 6. So that's not in its lowest whole number ratio. If we just talked about the ratio of carbons to hydrogens, you'd say for every 1 carbon, there's 1 hydrogen. You wouldn't say for every 6 carbons, there's 6 hydrogens. It's not the lowest whole number ratio. So the molecular formula is C6H6, but the empirical formula would just be CH. We could divide both of those by 6 to reduce it down. So like I said, formulas for molecular compounds might be empirical. It depends. So I have some example problems here. Let's try them out. So this is the molecular formula. So first we have water, H2O, and we need to look at it and see if we can reduce those numbers down to something smaller. Well, this is a 2, but if there's not a number next to an element, it really means that there's a 1. So I can't reduce that down. There's not a number I could divide both those by, other than 1, and it wouldn't change the formula. So the empirical formula for this first one is its molecular formula, and that's going to happen sometimes. It would just be H2O. Next, we have C6H12O6. You may remember this from biology. This is glucose. But if you look at these numbers, if you analyze these numbers, they're all divisible by a factor of 6. So if I divide every number by 6, I get CH2O. And the next one here, I have C12H22O11. Now, if I have a mix of even numbers like 12 and 22 and then odd numbers like 11, it's very difficult to reduce this number down. If I divide this by 11, I can reduce that down, but I can't divide 12 by 11. It's just not going to work. So this molecular formula is also an empirical formula, C12H22O11. Now, I'm not 100% sure why the Regents wants you to be able to do this. This might be applicable in some of the real work that chemists do in the lab. But you just need to be able to do this. You should know the difference between a molecular formula and an empirical formula, and you should know how to turn a molecular formula into an empirical formula. So you can think of an empirical formula like a reduced down fraction. It's the lowest whole number ratio of atoms in a compound. If you can divide all the numbers in a molecular formula by the same number, do it and find the empirical formula. And if you have a mix of even and odd numbers in a formula, you probably won't be able to reduce it down. And ionic compounds will never be able to be reduced down. Remember, a formula unit is already in its lowest whole number ratio. So if you see a metal bonded to a nonmetal and they're asking you for the empirical formula is already in its empirical formula.